Assalamualaikum guys, in this video we're going to proceed with continuous probability distribution. A random variable can be either discrete or continuous. Recall that a discrete random variable can take a value from 0, 1, 2, 3, right? All the value that consists of whole number. While a continuous random variable can take any value in an interval, right? Any value. So from 0 until 1, there will be a lot of value, other value in the middle of continuous variable. So graphically, this is how discrete value should look like, and this is how continuous value should look like. Alright? So in continuous probability distribution, for our syllabus, we are going to focus on only one probability distribution, which is called normal probability distribution. So normal probability distribution is known as an important distribution describing a continuous random variable in many applications. Normal distribution is often used, and moreover it plays an important role in methods of differential statistics, which will be discussed in chapter 3. If a continuous random variable has probability distribution with graph that is symmetric or bell-shaped, then the distribution of the random variable is called normal distribution. Why bell-shaped for normal distribution, you say? Look at this video. I hope that you understand why bell shape is normal. That is the shape of normal data in this world. Now, a random variable is said to have a normal distribution, right, with two important information with it. Right? Let's try to refer to its way to write the expression or normal distribution. Okay, we have x approaching to n, which is for normal, and in bracket you have mu and sigma squared. So basically, for the question of normal, mu and sigma squared are the most important things that you need to know before you can answer normal distribution question. Now let's try to see on how to look for its measure of standard tendency and dispersion. Okay? To find the mean, we look for the mean of mu. To find the variance, it is sigma squared, and to find the standard deviation, it is sigma. Okay? Or the third of sigma squared. Now let's talk about the shape of normal distribution a bit. By right, we know that the shape is a curve, a bell shape. Okay. However, we need to be clear that the shape is actually being influenced highly based on the value of mean and sigma, mu and sigma. Right? The change in this value will change the distribution. Okay, let's try to refer to these three picture of graph. Right? what can you say? This is actually a picture that contains two distribution of normal distribution. So if you look at the first one, it seems like it has only one graph, but it's actually overlap each other because these two distribution, right, are having the same value of mu and sigma. Hence, they are having the same distribution. Let's look at the second one. For the second one, as you can see, you have one that is quite tall and the other one that is quite short, right? So what makes it different? Right? They are actually are having the same middle value, which is the mean. Okay, we have the same value of mean that makes them in the center, same center, but one is high and one is small, one is quite low. That happens because they are having this different sigma. Sigma there is actually a standard deviation which indicate the spreadness, remember, or the dispersion. So we can say that for the graph that is actually a dotted line, maybe that graph is having the data for that graph is having large value of sigma because the spreadness is quite big. When it's spread quite big, the bigness will also come down. So for the other one, right, we can say that maybe the sigma is the value of sigma that is small, hence small spreadness. Okay, and for the third picture, third graph, as you can see, they are having the same kind of spreadness because they have the same height, they have the same spread, but they sit at different places. So why is that happening? Because they are having the same sigma but different mean. Mean represent the peak. Okay, mean represent the peak of each graph, normal distribution graph. So when they are having the different mean, the peak will also be at different place. So of course that's what changed the place for both of the graph. Right, that is about the shape of normal distribution and how mu and sigma affect the position and also the spreadness. Okay, so let's look a bit on the properties of theoretical normal probability distribution. We have 5 properties. So it should be bell-shaped curve, right? And the curve is symmetrical about the mean. And then the mean, median, and mode for normal distribution are equal and located at the center of the distribution. This is for the ideal normal distribution. And then it should only have one mode, right? Or we can call it unimodal. And the curve is continuous. Okay? So by this, it means that the tail for both of the side for this normal distribution graph, it is continuous. It never touch the x-axis. It will leave a small space along the x-axis, left and right. So it is continuous. It has no ends. And then the total area under the whole normal distribution curve is equal to 1 or 100. So that is about the properties of normal probability distribution. In the next video, we are going to talk about normal probability distribution, but not just any normal probability distribution. It is a standard normal probability distribution. In other words, it is a normal probability distribution that has been standardized. Okay, thank you.